Hey class, this is Mr. Ernest, and I'm going to be doing some problems for you. I'm sort of DIYing my lecture here, but hopefully this will help you if you were having problems with the week 2 worksheet, 5.4 and 5.5, and the week 3 worksheet, which I'll do next. I know if anybody needs help with week 1, I can do that, but I figured since that was review of what we were doing before we left the break that maybe you were able to do that without too much trouble. But I could be wrong, of course. Anyway, so with 5.4 and 5.5, we're talking about polynomials, specifically how to deal with polynomials with more than one variable and how to divide polynomials using those rules. So let's start with evaluate. Now, evaluate just means plug in the number. Plug in the numbers. In our case, numbers, because there's more than one variable. So with 8y squared minus 5xy, that's the expression that they give you. And then off to the side after that, they say x is equal to 2 and y is equal to negative 5. So basically, they just want you to replace these letters with their numbers. Since y is negative 5, we're going to write it in parentheses squared minus 5, and then x is 2 and y is negative 5 again. Okay, so that's just plugging in the numbers. Now we can do order of operations. If you remember, is PEMDAS, right? So parentheses, there's nothing inside the parentheses to do. So we move on to exponents. That's this one thing. So we're going to say 8 still there. And then this is going to be positive 25, because remember, a negative times a negative is a positive. When we square it, that's what we're doing. And then that's the only thing that had an exponent, so let's just bring everything else down. Boop. Now we're going to do multiply and divide at the same time. There's no dividing, so there's just this guy. So 8 times 25 is like saying how much is 8 quarters? That's $2. So in our case, it's 200, right? 2.00. And then you don't have to do that. You can use a calculator. It's the beauty of being at home. And then here we have two negatives being multiplied, so that's going to give us a positive. Again, that rule. And then 5 times 5 is 25, and then 25 times 2 is 50. So 200 plus 50 is 250. There's your answer. All right, that's the evaluate problem. After that, everything is just trying to go back over what we talked about in 5.1 through 5.3, which is add, subtract, multiply, but with multiple variables. So adding or subtracting, we got 3x squared minus xy minus y squared, and that's being added to x squared plus 10xy plus 4y squared. So if you remember, adding polynomials means combine like terms. We got to find the like terms. 3x squared and x squared are like, so they add to give you 4x squared. Boom. Done with those. And then we have negative xy and we have positive 10xy. Now they're different signs, so we subtract and the larger number keeps the sign. So we have 10 minus 1 is 9xy. Done with those. Now we have negative y squared and positive 4y squared. Again, different signs, so we subtract and we keep the larger number sign. So positive 3y squared. And we're all done with this problem. So it's about like, if you have a hard time doing that in your head, you can go off to the side and be like 3 plus 1, or you can say like is 4, or you can say 10 minus 1 is 9, and then you can say 4 minus 1 is 3. However you need to do the adding and subtracting. You don't have to go right to the answer like I did. But the key is finding like terms. Even if there was a minus sign here, you'd have to remember to distribute it into all three terms in the second parentheses before you start combining like terms, before you start doing the whole same sign add, different sign subtract. For number 3, it's asking you to multiply. Now there's a single thing on the outside of the parentheses. Let me get this right. All right, so we have a single thing, which is negative 6ab squared. And this guy, there's no pluses or minuses in the middle of it, so there's only one thing, a monomial. I wonder, oh yeah, that helps with the shadow, doesn't it? Okay, so the idea is we're going to distribute. into these two things. So we're going to have two negatives making a positive. We have 6 times 5 is 30. Now for each letter, we add the exponent. So A has a 1 and A has a 1. These two have invisible ones. AB is not a thing, a single variable. It's two different variables with their own exponents. So we got to write those little ones up there so we'll know that we're actually saying 1 plus 1 is 2. And then for B's, we got 2 plus 6 is 8. All right. And then the next one, again, negative, negative makes a positive. So we put a plus. And then we have 6 times 12 is 72. And then we have A times nothing else. And so we're going to put the A in our answer. Don't forget. He comes with it. And then we have 2 plus 2 is 4 for B. If you want to put the 1 here, you can, but that's all you got to do when you multiply by distributing. Okay. Number 4 starts with the dividing. Now with dividing, there's a rule that says that anytime you have the same base, you subtract the exponents. It's literally the opposite of when you multiply two things to the same base where you add the exponents. Here you're going to subtract the exponents. Now the first one is not meant to throw you off. Just remember that if there's a number base, you cannot divide those two. You can't say 6 divided by 6 is 1. That's bad. But what you can do is you can write that 6 once and you can say 16 minus 3. Okay? Don't bother multiplying that all out. That's a big number. All right. Number 5, it's got letters, so you're less likely to do something bad like dividing the base numbers. Okay, so we have x to the 7th, y to the 12th, divided by x squared, y to the 7th. And just like when we were multiplying with multiple variables, you added exponents for each letter separately. Well, here you're going to subtract exponents for each letter separately. Always top minus bottom. That's important. So 7 minus 2 for x means 5. And then 12 minus 7 for y also means 5. So we have x to the 5th, y to the 5th. Do not add 5 plus 5. Bad. Don't do it. Don't be that student. Okay? So that's the quotient rules, what we call it, where we subtract the exponents, don't touch the base. And next rule is the 0 rule, and that's because that sometimes when we subtract numbers, we might get 0 as an answer. So what the heck does that mean? It means that it cancels. So like if this was 6 to the 16 and this was 6 to the 16 minus 16 would be 0. But in all practical purposes, any number divided by itself is 1. So anything to the 0 power is 1. That's the rule. So 4 to the 0 power is 1. However, there's this negative that wasn't involved, so he's still in the answer. Negative 1 is the answer. So don't think of negative 4 as a single thing being raised to the 0 power. It's not. Just the 4 is. There's no parentheses. If there were, it would be positive 1, but there's no parentheses. Don't include the negative. Very similar problem number 7. You have 15y to the 0. So 15 and y are not together. They're separate. So y to the 0 becomes 1. And then you end up having 15 times 1, which is just 15. Okay? And then number 8 is the one where there is a parentheses. It's 5y in parentheses raised to 0. That means that everybody's involved, and that means your answer is positive 1. Okay? Okay, so that's the 0 power. You're not going to see a whole lot of it, but I do want you to understand that negative and a number are not together when it comes to exponents, like 0 power. And numbers and letters are not together when it comes to 0 powers and exponents. There's another exponent that we're going to talk about on the next, on week 3 worksheet, where this same thing's going to come up. All right, moving on. Number 9. So here we have a quotient being raised to a power, and that sounds like foreign language, so let's try it this way. You have a fraction raised to a power. What that means is that that power goes to both the top and the bottom. So in this case, a to the 3rd and 3 to the third happen. Now you can keep going with the denominator because 3 to the third is small enough. So 3 times 3 times 3 is 9 times 3, which is 27. There's the answer for number 9. Okay. Number 10, we have 4y, and that's over 5, and that's all raised to the second power. And here you have it going to both the top and the bottom, but the top has a product, has 2 things up there. So there was a thing that we learned, hopefully before we left, that anytime you raise a product raised to a power, everything gets that power. So in this case, instead of the 3 going to just the top and the bottom like this, the 2 is going to go to the 4 and the y and the 5. All of it. Everybody gets that power. It's kind of like the Oprah thing, you know? You get a car, you get a car, everybody gets a car. No? You guys too young for that? Okay. I'm just pretending like I'm in front of you and pretending like you're responding in the way that I think you're going to respond because, you know what? I've been isolated for too long. Okay, here we go. So when everything gets squared, the 4 gets squared, it becomes 16. The y gets squared, it stays the way it is, and 5 gets squared, it becomes 25. And then you're all done. So just remember, everything gets that square. That's the point. And then the last one, which is a more complicated looking thing, but it's still the same concept. We got 4p squared, y to the third, although it looks like it got cut off, and s to the fourth in the denominator, and that's all being raised to the 4th power. Now this problem is on there so that you can remember that if you raise something with a power all to another power, you multiply the powers. Not the number though. The 4 gets raised to the 4th power, and that's going to make us go 4 times 4 times 4 times 4. But for the p, we're going to say 2 times 4 is 8. For the y, we're going to say 3 times 4, which is 12. And then for the s in the denominator, we're going to say 4 times 4, which is 16. The only thing I'll caution you about is don't make that 16. That's bad. Okay, 4 raised to the 4th is not 16. It is, and put it like this, 4 times 4 times 4 times 4. It's actually 16 times 16, which is 256 if you wanted to write it out. Since you have calculators at home, it'd be okay for you to write that out. Okay? All right. So all of that is to prepare you for dividing monomials or dividing multiple term things by a monomial. Monomial, if you remember, is a one-term thing. Okay. Negative 24x to the 11th divided by 4x to the 6th. When we're dividing, it's important to separate the number and the letter. Remember what I was talking about that with x to the 0 or with numbers to the 0? The number and the letter are not together. So if you want to put a little dotted line right here, dividing them up like that, that's great. And now you can kind of cover up one side and go, oh, negative 24 divided by 4 is negative 6. 11 minus 6, because it's powers, is x to the 5th. And done. Nice, huh? Okay. Number 13, we have a kind of a longer looking problem. Negative 16x to the 9th, y to the 13th, z to the 5th, and that's all being divided by 4, x to the 4th, y to the 3rd, z to the 4th. So again, we put our little dotted lines in here between each letter and number, base numbers and letters. Then we can see there's 4 different things that I'm doing. So negative 16 divided by 4 is just negative 4. 9 minus 4 for x means x to the 5th. 13 minus 3 is 10 for the y. And then 5 minus 4 is z to the 1st, which I don't have to write the 1, but if you really want to, you can. I don't mind. And you're having online multiple choice quizzes, so you're really going to look for the one that doesn't have a power on the z. That means z to the 1st. But if you're doing your work and you want to write it just because it makes you feel better, please do what makes you feel better. You know, you're in the comfort of your own home. Okay, now this number 14 is a little tricky. Not too bad, but I do want to look at it. So we have negative 3x to the 13th divided by x to the 21x to the 7th. And if we divide this up again, we can see with the numbers, it doesn't work quite like it did in the previous two problems because the larger number is in the bottom. So we have to treat it like it's a fraction and reduce it. Divide by 3 in both the top and bottom, and you get -1/7. Cool? All right, so, and then x, you have 13 minus 7, and that's 6, and that goes in the top. And that's the answer. Again, you don't need the 1, but you do need the 7 in the denominator, and you need the x in the numerator. So that's the trick about dividing and subtracting. Whenever you subtract exponents, the answer always goes in the top. Now this is in the top, it was over 1. This is in the top, it's over 1, right? So just because there's a 7 down here doesn't mean it's any different. It stays up here in the top. Okay. Let's look at a binomial, a two-term thing being divided by a monomial. So on the sheet, you have -12x to the 9th plus 32x to the 6th, and it's all being divided by -4x to the 3rd. You know what? I'm going to write it just like you see it on the sheet, because maybe this is all you're looking at. I don't know. You're like, I don't want to open up the sheet and also watch this video. So what's going to happen is we're going to take this whole thing and we're going to divide it into him, and we're going to divide the same thing into him. They both get them, like distributive property. So if you want to see that written out, it looks like this. -12x to the 9th divided by -4x to the 3rd. And then plus 32x to the 6th divided by -4x to the 3rd again.